Skin is the largest organ on our body. It is also our interface with the external world. Having the ability to build a synthetic skin that can mimic the function of touch will enable us to not only restore the sense of touch medically, but also enable tremendous opportunities in inspiring new electronic materials development, new form of electronic devices, and they will find applications in wearable electronics, automobiles, robotics, and also displays and implantable medical devices. Here we made a piece of artificial skin that can sense touch and generate electrical signals that can communicate with brain. It's made of all plastic materials.
Touch sensing in humans is accomplished using thousands of sensors called mechanoreceptors that are distributed in the skin. In response to pressure, the mechanoreceptor produces electrical pulses. The electrical pulses are transmitted to the brain, where the signal is interpreted. The pressure determines how frequently the electrical pulses are produced. Small pressures induce only a few electrical pulses per second, while larger pressures produce pulses more frequently, up to several hundred per second. Our artificial mechanoreceptor mimics this process by coupling a pressure sensor with a flexible circuit layer that produces the electrical pulses. The sensor is made of pyramid structures of insulating rubber, filled with conductive carbon nanotubes. As the pressure on the sensor is increased, the carbon nanotubes move closer together and more electricity can flow through the sensor. As more electricity flows through the sensor, the circuit layer produces electrical pulses more frequently, mimicking the properties of real mechanoreceptors. The electrical circuit layer was produced by inkjet printing using a process developed at Xerox Palo Alto Research Center. Printing is a promising technology because it allows large sheets of flexible electronics to be fabricated at low cost. Here we show the artificial mechanoreceptor in action. The pressure sensor is mounted on a glove. As the sensor is pressed against a scale, electrical pulses are produced. The frequency of these electrical pulses increases with the amount of pressure. We envision that this artificial mechanoreceptor concept will inspire technologies that can be utilized in advanced brain-responsive prosthetics, providing a natural sense of touch.
So far, we have only built one type of mechanoreceptors. In the near term, we want to use some of the inventions we come up with during this work for wearable electronics applications and robotics. But over in the future, we want to truly mimic the biological skin.